All right, folks, we're continuing with special cases of rational functions. And here's one. This is a very common one, actually. You don't know that it's common, but I have seen this one probably 1,000 times maybe in my life. Maybe not, I don't know, maybe not 1,000, maybe let's go with 500. Okay, but we've got f of x is equal to x squared minus 16 over x minus 4. And so we want to graph this and we want to understand if it has any vertical asymptotes, horizontal asymptotes, y-intercepts, that kind of stuff. Okay, so here's what we got. We are going to factor the numerator and the denominator. Well, the denominator is already factored. The denominator is just x minus 4. That can't be broken down anymore. But this x squared minus 16 in the numerator, that is a difference of squares. It can be factored into two binomials that include the square root of 16 in them, okay? So x squared minus 16 becomes x plus 4 times x minus 4, okay? And if you're not sure about how that factors, you should go find one of my videos under college algebra. You should find one of the videos on factoring, and you're looking for the video on difference of squares, factoring, okay? All right, so now that we see this, look, we've got a common factor or a matching factor in the numerator and the denominator. We've got an x minus 4, which we're going to cross out, and an x minus 4, which we're going to cross out, which means that there is a hole at x equals 4. Okay, there is a hole at x equals 4, and now we just got to find out what the height is. How do we find out the height? Well, let's rewrite this. F of x is now equal to, what's left over after we've crossed out the x minus 4? The only thing left is x plus 4. So f of x is equal to the linear function x plus 4, except that x cannot be equal to positive 4. We can't plug positive 4 in. Now, to know the y value of the hole, we actually have to plug 4 in to f of x and find out what it would be if it was there. If we plug a 4 in, f of 4 is equal to 4 plus 4, and 4 plus 4 is 8. And so there is a hole at the point 4, 8. So we're going to go over to 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. And we're going to put a hole there. Okay, so there's a hole at 4, 8. And now we can graph this function by simply graphing the function x plus 4. We just graph whatever is left over, okay? Well, this is a linear function. It's in the form y equals mx plus b, where m is 1 and b is positive 4. So the y-intercept is positive 4. So we'll go up 1, 2, 3, 4. Y-intercept is positive 4. And the slope of the line is whatever's in front of the x, which is 1. Positive 1. That's up 1 over 1, up 1 over 1, up 1 over 1. So we're going to go up 1 over 1, up 1 over 1. And we're going to draw a straight line right through there. In this case, I'm going to go ahead and use a yardstick. And I'm going to line them up as best I can. That's probably the best I can. Now, when I draw the line, though, I want to be careful because I do not want to draw the line through the hole. I want to stop at the hole, skip over it, and then continue drawing the line. And so now you can see here's the graph of, this is not the graph of x plus 4. It's the graph of x squared minus 16 over x minus 4. This is the graph of a rational function. It doesn't look like a rational function because it doesn't have a vertical asymptote. It doesn't have a horizontal asymptote. It's a special case, but it is a rational function. And the reason we know it's a rational function is because only rational functions, only the graphs of rational, well, mostly only. For now, I'm going to say only, but I mean, there are exceptions. Graphs of rational functions have holes in them. And so this is the graph of a rational function. It looks like the graph of a linear function, but it is not completely the graph of a linear function because it is missing the point 4, 8. Okay, and that's why it's a special case. All right, let's do another one just like this. All right, here we've got one. We've got f of x is equal to negative 2x squared minus 10x minus 12 over x plus 3. Now, if you're not careful about solving this problem, you may think that this function has a slant asymptote and that it has a vertical asymptote at -3. And that would be a mistake if you did that. What you should do is you need to factor the numerator and find out whether there is a hole in this function, which there is in this case. But first, if you look at this, we can take a 2 out of all of these terms. But we're going to take a -2 out, because if we can factor out, if the lead coefficient is negative, we want to take the negative out. So we're going to have -2 times x squared. -10x divided by -2 is positive 5x. -12 divided by -2 is positive 6. Now this factors two numbers that multiply to 6 but add up to 5 are positive 2 and positive 3. So we've got -2 times x plus 2 times x plus 3 over x plus 3. All right, and I put the parentheses around here just so that you can see that it's a match with x plus 3. So we've got an x plus 3 in the numerator, an x plus 3 in the denominator, and we can cancel them out. And so now we know that there is a hole at x equals -3. Well, where is that hole? The hole is at x value -3. To find out where the y value is, we need to plug -3 into what's left over in the function. Well, what is left over? Our function is now basically f of x equals -2 times x plus 2. Well, now I'm going to distribute the -2 back in because I've already done my factoring. There's no more canceling to be done, so now I can put it back in. -2 times x is -2. -2 times positive 2 is -4. Oh, excuse me, I forgot to put an x in here, so whoops. All right, let's do this again. -2 times x is -2x, and -2 times positive 2 is -4. And so now if I plug the -3 in for x, and by the way, x cannot equal -3. This is the official statement of what this function is. If I plug -3 in, I get -2 times -3. That's positive, see, so -2 times -3. Isn't that equal to positive 6? Minus 4. 6 minus 4 is equal to positive 2. And so the hole is at -3 and 2. So let's go to -3, -1, -2, -3. Positive 2 is right here. Okay? And now we can graph -2x minus 4. It's a linear function. We go to the y-intercept of -4, -1, -2, -3, -4, put a dot there. And now we're going to do a slope of, the slope m is equal to -2. And so we're going to go down 2 over 1. From there we can again go down 2 over 1. We can line them up. Now when they line up, they should line up straight through the hole. The hole is a part of it, and it's a linear function, so it really should just line straight up, and sure enough, it does line up. Okay, now I'm going to draw a line, but I'm going to hit the hole, and I'm going to jump over the hole, because I don't want to get stuck in the hole. That I could hurt myself, and they may have to send for a rescue crew to get me out of the hole. So I didn't fall in the hole there, and you shouldn't fall in the hole either, so don't draw straight through the hole. So now you can see this is the graph of -2x squared minus 10x minus 12 over x plus 3. It is the graph of a rational function. It has a hole in it, but it looks like the graph of a linear function. And that is meaningful. It's just not meaningful right now. Remember, this class is called pre-calculus, which means you're getting ready. You're learning a lot of the knowledge and the skills necessary to begin learning calculus. And this is essential knowledge to begin learning calculus, especially this idea of having a hole in a function. That is critical. Okay, it's going to come back in calculus. All right, that's all I have for you for this special case. In the next special case, we're going to do quadratics. Okay, we're going to do special cases that look like quadratics.